Last week, in episode 350, I showed you how to build a versioned API for this store application, and we can access that by simply calling API/products in the URL, and we can interact through this app using JSON. Now currently, this API is completely public. Anyone can use this to edit and destroy the products. Now normally you'll want to restrict access to your API in some way, and there are a variety of ways to do this, and the proper technique depends on your application's requirements. In this episode, I will show you several solutions you can use to lock down an API so you can choose the one that will best fit your style of application. One of the simplest options is HTTP basic authentication. It's incredibly easy to do in Rails, and most API clients should have no problem supporting it. To add this, just go into the controller that's serving up the API, in this case this products controller here, and add a call to HTTP basic authenticate with, passing in a name, I'll set it to admin, and a password which I'll set to secret. Now you'll probably want to move these options into some kind of external configuration so they aren't stored in version control, and also if you end up needing to do this in multiple controllers, you can easily move it into a separate controller and subclass from that controller. So now let's try this out. I'll use the curl command to make a request to my application, add API/products path, and now I get access denied in response. And if we check out the HTTP headers, you can see the response is 401 unauthorized, which is the proper kind of handling to do with an API. But if I make another request, passing in the username and password admin secret, then I get the full JSON response like I expect. One thing to watch out for is that this password is sent in the clear, so make sure to use a secure connection or maybe a digest authentication. Now another way we could lock down this API is to provide the client with an access token. Let me show you how you could do this. First of all, we'll need some place to store this access token, and I like to generate a model called API key with an access token string column. Now there are many other columns that you might consider adding into here. For example, you could add a role column to determine what permissions this given key has, or reference a user through this, and that way a user can have many different API keys if they want to, and you can determine permissions through that, or maybe an expires at date time column to determine when a given token expires, and so on. But I'll just keep this model simple for now with a single access token string column. Then I'll migrate the database to create that table. Now going into this API key model, what we need to do is generate a random access token string each time a record is created. And I'm going to paste in the code for doing this. It's just a before create callback, which triggers this method here. And this calls secureRandom.hex, which is provided in Ruby 1.9, and this generates a random hexadecimal string value, and then it will trigger this again if it already exists to ensure that it's unique. You might also want to add a unique constraint on the database column as well. Now you can see this in action in the console. If I call API key.create, it's going to generate a new record with a random hexadecimal string value. Now, however you choose to generate this and display it to the client is up to you, but usually it's on some kind of profile page that the user can copy and paste into their API tool. So now what I need to do is restrict access to this API by requiring the token be passed in. And there are several ways we could do this. One is just as a URL parameter, such as access token equals that value, and then it would give me access to the page. So going into the products API controller, I will just do this through a before filter, call it restrict access, and then make this a private method down here, called restrict access, like that. And then here I need to fetch the API key based off of the token. So API key.find by token, actually access token, and then that's params access token. And then I want to respond with the unauthorized status unless we actually found an API key. So this head method will just render nothing and just set the status to 401 unauthorized. Let's try this out. Reloading the page here with the proper access token seems to work, but if I leave the access token off or set it to something that's invalid, I get a blank page. But you can see through curl here that is actually returning a 401 unauthorized response. Now passing the access token through the URL like this probably isn't the best solution, especially if the token doesn't expire. People tend to copy and paste URLs and you don't want them accidentally sharing their credentials. So instead, we can pass this access token through an HTTP header. Well, Rails actually gives us some controller methods to easily add this functionality. You can see in a before filter, we could just call authenticate or request with HTTP token, pass it a block, and if the block returns true, it will give them access. So let's try this out. So in our controller, instead of checking the access token through the URL parameters, I'll just comment this out and paste in a new restrict access method which uses this authenticator request with HTTP token method and just checks if that API key exists with that given access token. So now when a request is made to the API, it's going to deny access again with unauthorized response unless a header option is passed in here for authorization, and that should be set to token and set the token equal to that given token value. And then we will get a successful response. So you might want to mix and match these different token authentication methods to best fit the needs of your application, either through the URL parameter or the HTTP header. Now so far, the different solutions we've covered are pretty simple, but what if your situation is a little more complicated? For example, what if a user is able to log into your application and you would like other applications that use your API to be able to simulate logging in as that user and access their credentials, but only if that user gives that application permission. This is a common scenario in social networking applications such as Facebook or Twitter, and a great solution is OAuth. Now, I won't be covering OAuth in detail in this episode, but you can check out the site for more information. Basically allows you to secure an API and protect the user's data without requiring them to spread their passwords around to other sites. Now, I recommend you use OAuth 2, but it's still in draft form, so the documentation is a little rough. Thankfully, there are many projects available to help make it easier to implement OAuth in a Rails application. Doorkeeper is one of my favorites. It's still in early development, but is worth checking out, and I'll be covering this in further detail in this week's Pro episode. Now, I also recommend you check out the OAuth 2 gem. Many other projects build upon this gem, so it's a good idea to get a better understanding of how it works. Also, I'll be linking to several other OAuth projects in the show notes for this episode. Before I go, I want to mention one more thing, and that is with any of the solutions I've shown so far, it's very important that the API interaction happens over a secure connection, so be sure you're using SSL. Well, that's it for this episode. I hope you found it useful. In the Pro episode this week, I will create an OAuth 2 provider using Doorkeeper. I will then show how to set up OmniAuth as an OAuth client and use the OAuth 2 gem to securely communicate with the API. To watch that episode and all other Pro and revised episodes, just head on over to railscast.com/pro and then sign up there for just $9 per month. I have an application here for managing products. I can create new products or see the details of existing products or edit them. A pretty standard application here. Now, I would also like to provide a REST API so that I can manage products outside of this HTML interface. So how do I do that? Now, I already have a products controller which follows a RESTful style, so I could just use this, right? Just make a respond to block in here so I can respond to the HTML format and the JSON format, and for that I'll just render out a JSON response listing out all the products for this index action here. And then I can make a products.json request, and voila, there's an instant REST API, right? Well, there is a serious issue with this, and that is versioning. It's important that an API stay consistent. For example, I have this released on attribute which returns the date that the product was released on. But what if I want to restore and return the time as well, and I rename this column to released at instead of released on? Suddenly, I've broken any consumer of this API that used this attribute. So keeping your JSON API right alongside your HTML interface is often not a good way to go if you're trying to build a consistent API. Now, there are several gems to help out with this problem. Versionist makes it easy to handle version APIs in the routing, and it includes several generators. RocketPants is another gem which can help with building a REST API. It includes versioning and a whole lot more. The README is really nice, so check it out for more details. Now, in this episode, I won't be using a gem because doing this from scratch will give us a better understanding of how Rails routes work and how they can be applied to API versioning. So here are the routes for this application, and it's pretty simple with a products resource. And what I want to do is add a section of routes specifically for the API, so that way it stays separate from the HTML interface. So I'm going to do this using a namespace called API. And this means that any routes defined in here will be prefixed with the API path, and any controllers will be found under an API module. Now, you could also choose to add a subdomain constraint instead of using this API namespace, but this will work great for us here. Next, we have to decide how we want to do the versioning. One option is to just store the version as part of the URL. So that means we could do this with another call to namespace and say a version 1 so that any controllers or routes defined in here will be expected to be under that specific namespace. So for now, I'll just say resources products to serve up our products in a RESTful style. Now under my controllers directory, I need to make a new folder here called API and another directory called version 1. And then inside of here goes the products controller.rb file. So in here, I'll need to make a module called API and then another one called v1. And then I can place my controller class here called products controller and have it inherit from application controller. Now, alternatively, what I could do is have it inherit from maybe an API-based controller if I want to share behavior between all various API controllers. And then, of course, you could just fill this in with the actions you want to provide to your API. I'll just do that off camera here. So here I've just defined each action using a respond with call, so it responds in the JSON format. But this is a really simplified approach. You'll probably want to do something extra for your JSON API. And now when we visit API/v1/products.json, there's our JSON API. Now currently this requires that one somehow specify the JSON format. You can see if I remove the JSON extension, there's no API response. So here's a little tip to make JSON the default format. Under the API namespace in the routes, you can add a defaults option and specify the format and set it to JSON for this. And now reloading the page, it returns the JSON response by default. So far, things are working great, but what if we need to make a change that will break the existing API? For example, what if we want to rename this released on column? So I'll generate a new migration here to change that products released on column, like this. I'm just going to paste in the code for this migration file. It'll just rename the released on column to released at and make it a date time column. And then running rake db migrate will make that change. So now hitting reload in the browser, it now renamed the released on column to released at, and it is now a timestamp, so it's not a backwards compatible change. Now hopefully you have some kind of automated system set up so you know when you accidentally break the API. So let's work on getting this version 1 of the API working again. Now it's a little bit tricky here because I'm using respond with in this controller. I'd prefer to replace this with something like Rabble like I show in episode 322. This way I have more control over exactly what attributes are returned in the JSON response. But I'm okay with doing a quick hack here to get something working, especially if it's well covered in automated tests. What I'm going to do is just make a new class inside of the products controller class called product and just have it inherit from the actual product model. So this way, any references to this product class in the controller will use this subclass instead of the original product class. And I can override a method such as JSON in here to handle any behavior differently just for this specific version of the API. So I can call super to get the original JSON hash, and I can merge on any other attributes or make any other changes I want, such as adding a released on attribute, which will be the products released at, turned to a date type. One thing I forgot to do in this JSON method call is give it an options hash as an argument. So now when I reload this page, I have a released on attribute, and if I had automated tests, I should be back in the green now. However, I still have this released at attribute, which I think is a nice benefit because this way it'll ease the transition for someone who still has the old API. Technically, at this point, we don't really need to release a new version of the API, but if you get enough of these hacks and deprecations, you'll probably want to. To release a new version, we can just copy the app controllers API/v1 directory into the app controllers API/v2. And then going into the routes file, we can just copy this version 1 namespace and make a version 2. Now, if there's a lot of duplication here of the same routes, you might want to make a lambda and then just pass that same lambda block to each of these, but that's only if the routes are exactly the same. And then we can just go to the version 2 products controller here and remove any extra hacks that we might have, and change that module name to version 2. And now visiting version 2 of the API shows us the cleaner API without the deprecated released on attribute. Now when you follow this approach to versioning, it might look like there's a lot of code duplication going on here. The products controller in version 2 looks nearly identical to the products controller in version 1. but I don't consider this a violation of the dry principle because it's important to ask yourself, if I change the code in one version, will I need to change it in the other as well? And that's not really the case because you'll rarely go back to an older version and need to bring a feature back from a newer version. You're likely going to have different code in the older version to make it backwards compatible. Also, you'll likely remove an older version at some point, so doing extensive refactoring here I don't think is worth it. However, if you do want to, you could make a different kind of superclass here with the shared behavior that they both inherit from. Next, I want to talk about how we specify the version number. Right now, we just put it inside of the URL path, which is simple and direct, but many don't consider it to be a best practice. GitHub, for example, made this change, so instead of passing the version number through the URL, they pass it through the accept header. So how would we do something like this in our application? So going into my routes file, I'm going to replace the namespace with a call to scope, so that way I can specify what module to use, and also specify constraints. And the constraints logic is kind of complex, so I'm going to move this into another class. So I'll instantiate it here, I'll call it API constraints, and then I'll say the version should be 1. And then I'll do something similar for version 2 here, just replacing the version numbers. And I also want to add another option to pass into here of default and set that to true because I want this route to be the default one if no version is specified. So I still need to define this API constraints class, and I'm going to do that inside of the lib directory here. Just call it API constraints.rb. Now I'm just going to paste in the code for this class. It's pretty simple. All I'm doing at the top here is extracting out the options into instance variables, and then I'm providing this matches method, which the Rails router will trigger for the constraint, and I'm just checking if it's the default version or if the request accept header matches that given version string or whatever you want this version accept header to match. So you'll want to replace this with your application name or whatever you want it to be. And then for convenience, I'm just going to go to the top of my routes file and require that API constraints file there. So now after restarting my application, if I visit the API/products path, notice no version number in the URL here, it will return the default version, which is going to be version 2. And then in the terminal, I can use curl to specify the accept header. I'll just paste in the command for this, specifying the header option to accept that specific version number, version 1 here, at the API products path. And this returns a response which includes the released on attribute, which is the first version. Well, that finishes up this episode on making a versioned API. Thanks for watching. In this week's Pro episode, I will take a look at Meteor, which is a JavaScript framework for building rich client-side applications. There I will make the same raffling application which I did in previous episodes to compare it with Backbone.js and Rails. Even though this isn't specifically about Rails, I think it's important for us to be aware of new technologies and learn from them. To watch that episode and all other Pro and Revised episodes, just head on over to railscast.com/pro and then sign up there for just $9 per month.